Okay, we're going to move out of right triangles. We're going to start talking about what to do if we don't have a right triangle. We still can solve, but one of the ways we're going to solve is we're going to use what's called the law of sines. And this is going to be one of our options when we have a non-right triangle. The law of sines sets up proportions according to angles and sides. We take the sine of the angle and set it over its side, equal to the sine of another angle over its corresponding side. And of course you could have all three sides, three angles, but for any kind of proportion we're only using two of the pieces of information. So whichever two it has doesn't really matter, but you're using two of them. What's unique about proportions is that you can set them up however you like, as long as the corresponding parts are the same. So I can reciprocate and put sides on top and angles on the bottom. The reality is you want to put down, or you want to put on top whichever one you're solving for. So if I want angles, if I want to solve for an angle, I would set it up with the way you see here. And if I wanted to have a side, I would reciprocate it and I would put the sides up on top. So we're going to try a couple of examples here. Here I have a triangle that has angle 72 degrees, an angle of 43 degrees, and side A is 25 degrees. When you're given this piece of information and it says solve a triangle, you're finding all pieces, just like we did before with our right triangles. You're going to be finding all the sides, all the angles. Well, some of them are given to you. I know A, I don't know B, I do know C, I know side A, I don't know side B, and I don't know side C. I want to set up all the pieces I know, leave blanks for the spaces I don't, and I want to use them my property to fill them in. Now we should know our angle sum, our triangle sum property that says it has to equal to 180, so I don't really need to do any work on using the law of sines for the angle of B. I can just take 180 and subtract the 72 and the 43 and get 65 degrees, and that is good enough. You would not have to show any work for that. To find side B, though, I need to use angle B. And because I want side B, I'm going to put it on top, and I'm going to put its angle on the bottom. Now, I have to use A. I have no choice, but I always want to use the pieces I'm given. So side of A to angle of A. Multiply the sine 65 out. And now type that into your calculator. Please make sure to use parentheses appropriately or you will get errors. So we get side B is 23.8, and that's good enough for that. You don't need to go beyond more than one decimal place, unless directions specify differently. And so we're going to do the same thing for side C. C is to the sine of the angle C. And now I do have angle B, but remember this is a rounded answer, so I do want to use given when possible. So side A to angle A. Multiply the 43 to the 25. Use your calculator. Close your parentheses. And we get that it's 17.9. All right, so when you're asked to solve a triangle, make sure you're putting all 6 pieces of information in it. Okay, here is a second example where the triangle given is 34 degrees A, side is 18, side is 22. Now remember, whenever you're going to solve for an angle, you're doing your second function or inverse function, because that's the only way you can solve for an angle. What I'd like you to do is try that one on your own and bring it to class tomorrow, and we will go over it there. Now, the law of sines has what's called an ambiguous case. With the law of sines, there is the possibility that two triangles exist, one triangle exists, or no triangle exists. Now, if I give you the one triangle, that's all there is. But if all I gave you was a piece of information, I told you one angle is this, one side is this, and the other side is this, you don't know if it makes two triangles, one triangle, or zero triangles. Now, I'm going to go through the proof of this with you in class as to why this works, but I'm going to just jump to the examples on how to always derive a situation as to how to always make it work. So I'm going to prove as to why we get two triangles, one triangle, and zero triangles. But we're going to go through three examples where we actually get two triangles, one triangle, and go through that method on how we do it. Because we have to have a method to always figure out which one it is. And every single time you do the law of sines, this possibility exists. Tomorrow when we do law of cosines, there's only one option. But today with law of sines, we have to always consider that two triangles can be made. So the first thing we do is we're always going to assume two triangles can be made. All right, and what that means is we're going to set up our law of sines. So I would say I have side B, that means I want angle B. So I'm going to put angles on top, and side B is 12. I know angle C, and I know side C. I'm now going to solve this for B, which means I'm going to be doing the inverse. All right. Type that all in your calculator. So we get 12, or the inverse of sine, 12 sine 40 divided by 9. And we get angle B is 58 point, and that rounds it. So angle B is 59 degrees. All right, so we just do it normal and like, okay, that's fine. Well, what we're going to do is we're going to say triangle 1 has 59 degrees. Well, in order to be triangle 2, it would have to be 180, or the supplement, minus the 59. So triangle 2, angle B, would be 180 minus 59 for 121 degrees. And this is always going to be the case. We're always going to let the angle we found be the reference angle in quadrant 1, and subtract it from 180, and that's going to be the obtuse angle in quadrant 2. Now, either triangle doesn't matter. We know what angle C was. It was given to us. So angle C was 40. Now we're going to use the fact that the sum of triangles is 180 degrees. If I can add these up to two triangles that within 180, then I get two triangles. If I can't add them up, then I don't get two triangles. And that's exactly how easy and simple as it is. They either add up to 180 or they don't. So on here, if I have B is 59, C is 40, that must mean A is going to be 180 minus those, which is 81 degrees. So for sure, one triangle exists. Over here, I have 180, subtract 121, and 40 means angle A would have been 19 degrees. Two triangles exist. Only because I can add them up to 180. And that's all we're looking for on it. All right, so let's try another one. If I tell you angle B is 52 degrees, Angle or side A is 8 and side B is 10. I want to determine, is there two triangles, is there one triangle, or is there no triangles? Well, we're always going to assume there's two. So I'm going to go through the law of sines, just like if it was any other normal problem. And I'm going to, I know angle B, side B, so I want to find angle A since that's the side that's given to me. So sine of angle A over 8 is sine of 52 over 10. Using my law of sines, I know that A is going to be the inverse of 8 sine 52 over 10. Now we can type that all into the calculator. Second sine 8 sine 52 divided by 10, and we get that angle A is 39.1 degrees. Now, triangle 1 has angle A at 39.1. Triangle 2 will have A at 180 minus 39.1. So that's 140.9. Triangle 1 has angle B at 52 degrees. Triangle 2 has angle B at 52 degrees because that's given. So it has to be true. Angle C then is 180, subtract those, for 88.9 degrees. Angle C, when I subtract 180, subtract 140.9, subtract 52, I get a negative. That can't happen. Therefore, triangle 2 does not exist. Only one triangle exists. So, again, just that simple. It didn't add up to 180. It doesn't work. All right, so let's try one that none of them work. Here I have angle C is 21, side A is 15, side C is 3. So we're going to take sine of 21 to 3 is sine of A to 15. So A is the inverse of, when I put this in the calculator, I get second sine 15 sine 21 divided by 3. I get an error. That means I can't even make one triangle. 0 triangles exist. So like I said, in class I'll show you and I'll prove to you why that is true. But for this assignment, we're going to go through and we're going to use our law of sines, setting up angles to sides or sides to angle, whichever relationship it is that we're trying to solve for.